before we get into the mathematical models for learning curve effect that we are showing in this video, I suggest you to watch and learn other previous lesson videos for this class about the concept of productivity improvement approaches, and that will also apply for the semester project that we are going to start today. So let's go to the learning curve effect again, and we have two approaches for the mathematical models. The first one is arithmetic approach. Arithmetic. So let me review what is learning curve. So when we do something have require repetition, we improve our productivity that realized in terms of saving the cost and time to prepare, which is realized in the vertical axis, and depends on the number of repetition. The more we repeat the same work, the more time and cost we save, and that we're talking about the learning curve effect or experience. More experience, do the same work, we save more time and cost. And how to realize that? There are two approaches to do. The first one is arithmetic approach, and how that go. The first equation for today is Tn equal to T1 times L power n. Let's explain what is that about. So T1, that is the unit cost, or can be time, depends on what factor we are looking at. As you can see in that vertical here, cost or time to prepare of the first unit. And then similarly we have Tn, so it will be the unit cost or time of the n unit. And L is learning rate. And it depends on the nature of the work, the repetition, depends on the skill, depends on the people. Then the learning rate are not the same, and that realized with L. And then N, it will be the where the N's more in that equation. To N, it is the number of times T is double. So number of time T this ball, for example, from 1 to 2, we have one time double. 2 to 4, then another one time. So from 1 to 4, it will double twice. So let me realize that with the example here. Example, if we have T1 equal to, for the first repetition, we need 10 labor hours. And assume this repetition learning rate is 70%. Then what should be the time prepare for the fourth unit? What is T4? What is T4 will be? So the first unit I need 10 hours with the learning rate 70%. What is the time for the fourth unit to complete? So with that, as you can see, with the 4 unit, you have, so we have fourth unit will requires doubling twice, as I mentioned earlier, doubling twice. Why that? You have 1 to 2, the first double, and then 2 to 4 is a second double. So from that we can have the T4. So we have T4 equal to T1 10 time learning rate L power n 0.7 and n small is 2 because that doubling twice, so it will be 4.9 labor hours. So that what we have for that one. It's still confusing. How about if we want to find out what is the time or the cost required for the 100th unit? So how many double? What is n small? So that is challenge for the arithmetic approach. That's why we go to the next approach. We call it logarithmic approach, and that should be applied easier than the first one. So it can be able to determine costs or time for any unit. Otherwise, with that one, like I say, to find out the 100th unit, how many double, what is n small, to apply in the arithmetic approach. So that a little bit challenged. That's why we go to the logarithmic approach. Can apply to any unit, and then the equation become t n it equal to t1, so it's the same, but now it equal to n power b. We already defined tn, t1, and n is the n unit. You can see now b. What is b? So b equal to b equal to log of L, learning rate, over log of 2, and that divided by at the slope of the learning curve. The slope of learning curve. So if we go to this one, at any given point, as you can see here, any given point, the slope of learning curve, that's what we are talking about, and that is b in there. So let's apply that in quickly in problem 1. The first unit take 100 hours with the learning rate. So the first unit, so as you can see, that one is t1. The learning rate 80%, so that is L. 5 hours for 8 units. 5 hours for 8 units. So with that, we can use either method. The first one, we can use the arithmetic approach. And the equation become a T8. What is the 8th unit? So as you can see, this is 8, so T8. What is the question asked? And we already know that it's T1 times L power n, and T1 is 100 hours, L 0.8, and the number of times T is double. From 1 to 2, 1 double, 2 to 4, 1 double, 4 to 8, another double, so it double 3 times. So from that we can have n equal 3, and that we can have equal to 51.2 hours. So that we use arithmetic approach. And then if we use the logarithmic approach, then it become easier. We have that equation here. We need to determine slope of the learning curve. So we have b equal to log of L over log of 2. So we have log of 0.8 over log of 2. With your calculator, it will be negative 0.322. And then from that, we can have T8 with the equation T1 and capital power B. So T1 and capital power B, plug in 100 hours time n, and it n capital, so it's 8 number of units in GC, 8th unit, B negative 0.322, and with that we have answer about 51.2 hours. So that it will be much easier when the problem don't ask you to use any specific approach. You logarithmic, that easy to apply directly for the learning curve effect. In the next video, we will solve the problem 2 for learning curve effect as well.